So we're going to talk about how to find the area of a polygon here. So remember, a polygon is a figure that has all straight sides, it's closed. And in order for us to do this, we're going to need to make sure that we know it's a regular polygon. So what a regular polygon means is that all the sides and all the angles are going to be the same. So I'm going to go ahead and label that here. So I've got all my sides being the same, and then all my angles are the same. Now, the only other information that we're going to need to be given is one of the side lengths, and so I'm just going to label this side length 10. Now, we should be able to find out how to calculate the area of this thing with just this amount of information. So up top, I'm going to make sure we make a note again. This is a regular polygon. So as far as calculating the area of a non-regular polygon or an irregular polygon, that's something that you could do by breaking up into pieces. But anyways, we're going to look at just regular ones here. So the next thing that you want to do in order to figure this out is break this up into pieces that we do know how to calculate. So this right here is something that I don't know how to calculate yet. So what I'll do is break this up into triangles. So I'm going to find the center, and I'm going to break this up into individual pieces here. Now, all these triangles should be the same as each other. This distance here to the edge is called the radius. It's called the radius because if you draw a circle around the outside, it's the same as the radius of the circle. So that's a radius. Now, if I knew the area of one of these, I could multiply it by 5 and find the area of all of them. So I'm going to go ahead and disregard the other ones for now. I'm just going to look at one of them. So I'm only going to look at this one triangle. I'll find the area of this, and then I can multiply it by 5, and I should be able to find the area of the rest of it. So in order to find the area of a triangle, you need the height. So in a polygon, this height has a special name. It's called the apothem. A-P-O-T-H-E-M, apothem. I know if you sound it out, it might look like apothem, but apothem is the correct way to pronounce it. So this apothem, we use the letter A as far as an abbreviation goes. Now, I need other information because even though I have this 10, this height is going to intersect at a right angle. I could label this 5, and I could label this 5. That's still not enough information to find the area of this triangle. I don't have enough other information. This 10 is not equal to this. I mean, there are polygons where that's true, only one actually. But in this case, it's not going to be true. So we need to be able to find other information. The other piece of information that you can figure out from this is what the angles are. So these angles all should be the same because it's a regular polygon. And I should be able to calculate these using n minus 2 times 180. If you remember, it's a theorem that we've done before. This gives you the sum of the interior angles. So I should be able to calculate this. N minus 2, remember n is the number of sides, times 180. That comes out to 540. And if I divide that by 5, because there are 1, 2, 3, 4, 5 angles, 540 divided by 5, that's 108 degrees per angle. So that means if the whole thing is 108, the individual pieces are 54 and 54. Remember that they're going to be the same because all of these are the same, and it splits these into equal pieces. This is an isosceles triangle, so they have to be the same. Alternatively, you could have found, if you wanted to, the central angle. If that's easier for you, the central angle can be found because in a circle there are 360 degrees. And if you divide that by 5, 1, 2, 3, 4, 5, you can get that is 360 divided by 5 is 72. And that means 72 would be this whole angle here. If you cut it in half to figure out what the individual ones are, 72 divided by 2 is 36. So this would be the top angle. That would be here, 36. So whichever way makes sense to you. Both of them are fine. You can either use the central angle and divide it to figure out what this individual angle is, or you could use the n minus 2 times 180 to get the sum of the interior angles to figure out what that angle is. So I'm going to take this triangle and draw it a little bit bigger outside of this picture because I think that that's going to be a little bit more helpful. So this triangle here, I'm just going to draw again. We're going to basically zoom in. It's not perfect, but again, we need to be able to find the apothem. We know that this is 5, this is 5, this is 54, and this is 36. So based on what you've studied about trigonometry, you should be able to find the other sides of this triangle. As soon as you have one angle and one side, you should be fine. I can figure out what I need to use by looking at SOHCAHTOA. So you can see that. Remember that I'm going to use the 54 here. You could use the 36 if you want to. But since I'm using the 54, I have the opposite side, which is something I need to find. And then the adjacent side here is the 5. So I need to be able to use one that involves the opposite and the adjacent side, and that's tan. So the equation that you can set up is tan of 54 degrees is equal to the opposite over the adjacent side, so a over 5, which means 5 tan of 54 is equal to the apothem. So if I look at what that is, 5 tan 54, and again, make sure that you're in degree mode. That's important. So 5 tan of 54 comes out to 6.88. Now, since I'm going to round to the nearest hundredth at the end of this, usually that's the default if it doesn't say. I'm going to go to the nearest thousandth in this case, so 6.882 when you round it. Remember, if you want to be accurate to 2 decimal places at the end of the question, you need to go to 3 decimal places in the middle of the question. All right, so that is 6.882, which is great because now I can find the area of this triangle, which is 1/2 the height times the base, which is 5 and 5, which is 10. So if I do that, 1/2 6.82 times 10, and you get 34.41. That's one triangle. So since this is one of the triangles and there's 5 times 5 because it's a pentagon, that comes out to 172.05, and this is square units. So that's what the area of this is. Now, in general, there is a formula for the area of a polygon here. You'll notice that no matter what we do, if you think about it, no matter how big this was, you could still split it into triangles. And the number of triangles is just based off of the number of sides. So in general, you've got 1/2 times the apothem times the base times the number of sides. So the way that gets generalized is, so I'll do this, I'll make sure I write this in general. So the area of a polygon, a regular polygon, is going to be 1/2 the apothem times the perimeter. Now the reason it's the perimeter, remember, is because we took the base of this triangle, which was 10, and we multiplied it by 5. And in our case, 10 times 5 is 50. That was the perimeter. So that's where that comes from. So I've got 1/2 A and the perimeter. So that matches up with what we did here. 1/2 that, and then squeeze that over for that. So you can see that in general, the area of a polygon, 1/2 area times apothem times the perimeter. So that's where the formula comes from. You can just use this every time. You're still going to do the same process here with the trigonometry. So that's how you find the area of a regular polygon.